So in the previous video we have covered about the case first, that was when k is equals to 0. Here we are going to learn about case 2, where k is equals to positive number. Let's assume it as a p square. Why it is a p square? Because if you consider any value of p, the p square will always be positive. So this will be a case 2. Okay, so what was the equation we had here? I'm going to write it once again. This equation I am going to write once again. T double dash upon c square t double dash upon c square t is equals to k, and here it was x double dash over x is equals to k. Now we have to solve for both t and k. So how I'm going to solve it? Let's firstly solve for t. So here we are given t double dash minus kc square t is equals to 0. Put k is equals to p square. So it will become t double dash minus p square c square t is equals to 0. Now this is a second order differential equation. How we are going to solve it? If I assume t double dash is equals to d square. Okay, so it will become d square minus p square c square t is equals to 0. Now what will be our auxiliary equation? You must know about this. We need to find out the auxiliary equation where we put d is equals to m. So it will become m square minus p square c square is equals to 0. So m became plus minus pc. So we know already, like when we solve the differential equation, if the roots are real and distinct, if roots are real and distinct, so what? T will be equals to c1. I think 4 variables were already there. Let's take it c5 e raised to power, what is our first root? pc. Here we have we need to find out it is in the term of t. So here I'll need to check it, where I have written t dash, t double dash. Okay, we have done with respect to t. So when I did a m square p square is equals to this, and we are now finding the value. Correct. So t is equals to pct e raised to power m1x plus c2 e raised to power m2 e raised to power minus pct. This is our second equation. Correct. So I'm going to write it as this. Now we need to solve it for x. So if I solve it for x, here we are already given x double dash minus kx is equal to 0. Now I have already taken d square is equals to x double dash. Let's take d dash square is equals to x double dash. So this will become d dash square, d double dash square minus k x is equal to 0. Let's put k is equal to p square. This will become d double dash square minus p square x is equal to 0. Now I'm going to find the auxiliary equation. So we can put, let's say, m dash square minus p square is equal to 0. M dash will be plus minus p. So these are our two roots, plus p and minus p, which means these are also real and distinct. Real and distinct. So what will be the value of x here? X will be c7 e raised to power m1x plus c8 e raised to the power m2x. These are the two solutions. Like these are the values of x and t. So to find out the value of u was x times t. So u is equal to c7 e raised to the power px plus c8 e raised to the power negative px multiplied with c5 e raised to the power pct plus c6 e raised to the power negative pct. This is our final solution for the u. Now we will do for the third case, that is when k is negative. Let's cover it in next video.